Okay guys, so let's start discussing the JEE Main pattern exercises for the chapter Binomial Expansion. The first question says that in the expansion of x plus a whole to the power n, the sum of even terms is e and that of odd terms is o, then OE is equal to what? So, you know that x plus a whole to the power n is actually equal to the sum of even terms plus the sum of odd terms, so it is equal to o plus e. I am being asked to compute OE. So, if you observe, what is O plus E whole square minus O minus E whole square? What is this? This is equal to nothing but 4 times OE, right? And you know that this is sum of even terms plus sum of odd terms. If I talk about x minus a whole to the power n, what would this be equal to? This will be equal to O minus E, isn't it? If this is O plus E, this will be O minus E, right? That's how the expansion is, different of x minus a to the power n from x plus a to the power n. So, over here, if this is the very valid thing, then OE is equal to O plus E whole square. So, O plus E is this. So, x plus a to the power n squared, that means 2n, minus O minus E whole square, that is x minus a whole to the power n whole square upon 4. That is what is your OE. Is it understood? So, therefore, we basically say x plus a whole to the power 2n minus x minus a whole to the power 2n whole upon 4 is actually equal to the value of OE. Easy enough? Next question is the coefficient of x to the power 4 in the expansion of x by 2 minus 3 by x square whole to the power 10. Let's see. So, over here I am saying, suppose there is this rth term, or I should say r plus 1th term, which basically has x to the power 4 as its very coefficient. So, tr plus 1 is what? It is 10 cr, because this is 10, x by 2 whole to the power 10 minus r minus 3 by x square whole to the power r. This is the general r plus 1th term in the expansion this. So, you get 10 cr x to the power 10 minus r minus 2r. So, 10 minus 3r, 2 to the power 10 minus r, minus 1 to the power r and 3 to the power r. Clear? Everything has been brought in the numerator. So, this is what? 2 to the power r minus 10. Because this is 2 to the power minus of 10 minus r, which is r minus 10, then this is minus 1 to the power r, 3 to the power r, this already we have taken upstairs, right. So, if this is what is the r plus 1th term, I am wanting the coefficient of x to the power 4. So, I basically want that 10 minus 3r should be equal to 4. That means 6 is equal to 3r or r is equal to 2. So, it is basically the third term which has x to the power 4 in it. So, the third term becomes what? Obviously, x to the power 4 is there, because for r equals 2, this is x to the power 4. Then it is 10c2, because r is 2, 10c2, 2 to the power 2 minus 10, which is 2 to the power minus 8, or 1 upon 2 to the power 8, minus 1 to the power 2 is 1 only, and this is 3 to the power 2 into x to the power 4. So, what is the coefficient of x to the power 4? Coefficient is this, and the value when you evaluate, it comes out to be 405 by 256. That is what is the coefficient of x to the power 4 in this binomial expansion. Clear? Now, we have the next question, which says that what is the middle term in this expansion. Let's see. Question is about the middle term. Now, over here, if you remember the very algorithm of calculating the middle term, because 2n is an even number, 2n is an even index. So, therefore, 2n by 2 plus 1th term is the middle term. That means n plus 1th term is the middle term, right? What is the n plus 1th term? So, index is 2n. 2n Cn, 1 to the power 2n minus n, that is 1 only into x to the power n. So this is what 2n factorial upon n factorial into 2n minus n, that is again n factorial into x to the power n. Now 2n factorial can be written as 1 into 2 into 3 into 4 and so on, 2n minus 3, 2n minus 2, 2n minus 1, 2n whole upon n factorial into x to the power n. Now I can alternatively write this as what? I can write this as 1 into 3 into 5 and so on, 2n minus 3, 2n minus 1, all the odd terms together, multiplied by all the even ones. So 2 into 4 into 6 and so on, 2n minus 2, 2n, right? 2n minus 2, 2n whole upon n factorial into n factorial, and this multiplied by x to the power n. Now you basically have 1 into 3 into 5 and so on, 2n minus 1. From here you can see 2 is coming out common n times. So you basically get 2 to the power n, and now you are left with 1 into 2 into 3 and so on up till n, which is nothing but n factorial whole upon n factorial into x to the power n. So your answer comes out to be 1 into 3 into 5 up till 2n minus 1 into 2 to the power n into x to the power n upon n factorial. That is what is the n plus 1th term or the middle term. Okay. So what is your answer? This is your answer, 1 into 3 into 5 up till 2n minus 1 into 2 to the power n whole upon n factorial times x to the power n. Moving on to the next question, we have the greatest term in the expansion of 1 plus 3x whole to the power 54 when x is given to be 1 by 3. What is the greatest term? Again, a very basic algorithm which is going to come into picture over here. You calculate TR plus 1 and you calculate TR and then you calculate the ratio. TR plus 1 is 54 CR 3x to the power r whole upon 54 CR, this is TR, 54 CR minus 1, 3x to the power r minus 1. X is given as 1 by 3, so this eventually becomes 1 only because x is 1 by 3, 3 into 1 by 3 becomes 1, 1 to the power r, 1 to the power r minus 1 is that only. So here you get 54 CR upon 54 C r minus 1. This becomes 54 factorial upon r factorial into 54 minus r factorial, and here you have 54 factorial r minus 1 factorial 54 minus r plus 1 factorial. Fine. So obviously this gets cancelled out. What are you left with is this can be written as r minus 1 factorial 54 minus r plus 1 into 54 minus r factorial whole upon r into r minus 1 factorial into 54 minus r factorial. So very clearly this gets cancelled out, this gets cancelled out, you are left with 55 minus r upon r. Next what you do? You consider TR plus 1 upon TR greater than 1. So you consider 55 minus r upon r greater than 1. From here you get 55 minus r is greater than r, or 55 is greater than 2r, or r is less than 55 by 2, which is 27.5. Clearly this is not an integer. We separate the integral part of it, which is 27, and plus 1th term is what is the greatest term. So 27 is the integral part, and therefore 28th term will be my greatest term. I just followed the algorithm, nothing great, right? Next we have the coefficient of x cube y to the power 4 z to the power 5 in this expansion is what? Let's see. So based upon multinomial expansion, the concepts should be very, very clear. You should know that xy plus yz plus zx whole to the power 6 is equal to summation 6 factorial upon r factorial into s factorial into t factorial, xy to the power r, yz to the power s, and zx to the power t, such that r plus s plus t is 6. So from here you get what? Summation 6 factorial upon r factorial, s factorial, t factorial, r plus s plus t is 6. This becomes x to the power r plus t, y to the power r plus s, and z to the power s plus t. You want the coefficient of x cube, y to the power 4, z to the power 5. So you want r, s and t's value such that r plus t is 3, r plus s is 4, and s plus t is 5, such that r plus s plus t is 6. If r plus t is 3, s automatically comes out to be equal to 3. If r plus s is 4, t comes out to be 2. And if s plus t is 5, r comes out to be 1. So r should be this, t should be this, s should be this, to give you basically x cube, y to the power 4 and z to the power 5. And therefore, for r equals 1, t equals 2 and s equals 3, if I get here x to the power 3, y to the power 4, z to the power 5, its coefficient is going to come from here. Coefficient will be what? 6 factorial upon 1 factorial, 2 factorial, 3 factorial, which is this, right? Eventually becomes what? 6 into 5 factorial upon 6 into 2, which gives you 120 by 2, that is 60, and so your answer is that the coefficient is 60. So basically you get 60, this is 60, 60 x cube y to the power 4 z to the power 5, so coefficient of this is 60. Next question says what? Let's see. If C0, C1, C2 up till Cn are denoting the binomial coefficients in this expansion, then what is this expansion of? Let's see. So here I can see this is AC0 plus A plus BC1 plus A plus 2BC2 plus A plus 3BC3. So in short I can write this as, you can see over here it's already there, you can write it as A plus RB NCR. Okay, A plus RB NCR, R going from 0 to n. Because Cn is nothing but NCn, C2 is nothing but NC2. That's how we denote the binomial coefficients. So this comes out to be A times NCR plus summation RB times NCR. Fine. A comes out common, you're left with summation R going from 0 to n NCR, which you know is 2 to the power n, plus here what I'm going to do is B comes outside, I have R varying from 0 to n, R into, I can write NCR as n by R, n minus 1 C, R minus 1, R cancels, n comes outside, you get n times B, summation n minus 1 C R minus 1. Now if summation NCR is 2 to the power n, summation n minus 1 CR minus 1 is 2 to the power n minus 1. Right? 2 to the power n minus 1 comes out common, you're left with 2a plus nb. Clear? And that is what is the very value of this summation. It is what? 2 to the power n minus 1, 2 to the power n minus 1, 2a plus nb. Clear? The next question says that if x is very small in magnitude compared with a such that this is equal to this, then the value of k is what? Now over here for large index we have done the expansion. How do you basically talk about this term? How do you expand it? How do you find k? Let's see, a upon a plus x whole to the power half plus a upon a minus x whole to the power half. I can divide numerator and denominator by a. I am going to get 1 upon 1 plus x by a whole to the power half plus 1 upon 1 minus x by a whole to the power half. Or I can write it as 1 plus x by a whole to the power minus half plus 1 minus x by a whole to the power minus half. Now you can very easily expand, right? For larger index, for different index, we have done this expansion. What is this? 1 plus nx plus n into n minus 1, n into n minus 1 by 2 factorial x square. And then because it is very, very small, you can just avoid writing the further terms. Right? This comes out to be equal to what? Plus this expansion, so this becomes 1. What is this? This is minus 1 by 2 x by a. Here you are going to get plus 1 by 2 times x by a. This becomes what? Minus 1 by 2 into minus 3 by 2. That is 3 by 4 into 2, that is 3 by 8. So here it will be plus 3 by 8 x by a whole square. Fine. So you can see when you add, you get 1 plus 1, that is 2. Minus 1 by 2 x by a plus 1 by 2 x by a gets cancelled. You have, this is 3 by 8. This is 3 by 8 completely. We just evaluated. This is 3 by 8. So 3 by 8 plus 3 by 8 is 6 by 8, which is 3 by 4. So you get 3 by 4 times x by a whole square. See, we were basically avoiding writing the further terms because here the expansion only requires up till here. No cube expression is required to compute the value of k. So why to basically bother ourselves to further write the expansion? And therefore, we have obtained the result. It is 2 plus 3 by 4 times x square by a square. 2 plus 3 by 4 times x square by a square. So k comes out to be equal to 3 by 4. Clear? Now we have the next question. In the binomial expansion of a minus b whole to the power n, 5th and 6th term add to give you 0. Then a by b is equal to what? So 5th term and 6th term are adding to give you 0. This is t4 plus 1 plus t5 plus 1. Fine. So now what you have is you have nc4 a to the power n minus 4 minus b to the power 4 is same as b to the power 4. This plus this is actually coming out to be 0. So this plus again nc5 a to the power n minus 5 minus b to the power 5 or b to the power 5, and here it will be minus 1. Now I can write this as nc4 a to the power n minus 5 plus 1. Plus 1 is going to give me 1a over here, and this is b to the power 4 equal to nc5 a to the power n minus 5 b to the power 4 plus 1. So why did I do this? Obviously because of this. And now what I have is a by b is nc5 upon nc4. A upon b is nc5 upon nc4, which is n factorial upon 5 factorial into n minus 5 factorial multiplied by n factorial upon 4 factorial into n minus 4 factorial. Clear? So n factorial cancels. This is 5 into 4 factorial. So this gets cancelled out. This becomes what? N minus 5 factorial. N minus 5. What is it? This is n minus 4 minus 1. What you get next is, this becomes a by b is equal to, you have n minus 4 into n minus 4 minus 1, that is n minus 5 factorial whole upon n minus 5 factorial into 5. So you get n minus 4 by 5 is what is coming out to be the value of a by b. So you get n minus 4 by 5 as the answer. Next we have the number of irrational terms in the expansion, this is what? So how many irrational terms can you find over here is the question. Let's see how many are there. If I talk about this expansion, this is 8th root of 5 plus 6th root of 2 whole to the power 100. How can I write this? This is summation 100 CR 8th root of 5 to the power 100 minus R, and 6th root of 2 to the power R going from 0 to 100. So there are 101 terms. What do I want? When is the very time when I am going to get rational terms and irrational terms? See, these are the terms. I am going to get rational terms when this is an integer and this is an integer, right? For rational, I should get this as integer and this as integer. That means 100 minus R should be divisible by 8. 100 minus R should be divisible by 8. R by 6 should be R should be divisible by 6. 100 minus R should be divisible by 8 and R should be divisible by 6 for these to come out to be integers, and hence this comes out to be rational. So 100 minus R should be divisible by 8, that means 100 minus R can be equal to 0, 8, 16 and so on up till 96 because 100 is the limit. And R eventually from here, what should you have? So 100 minus R should be having or should be a multiple of 8 and R should be a multiple of 6. So R can be 0, 6, 12 up till 96. So for terms to come out to be rational, 100 minus R by 8 should be an integer, or I should say 100 minus R should be one of these and R should be one of these. That means what are the values of R which satisfy this also and this also? That means what are the values of R for which I can say that 100 minus R is divisible by 8 as well as R is divisible by 6. So I get 12, 36, 60 and 84. These are the 4 common values of R such that 100 minus R is divisible by 8 and R is divisible by 6. So for these values of R, I get 4 rational terms in the expansion. Therefore, 4 rational terms are there in the expansion. 101 total terms are there from 0 to 100 minus 4 rational, which gives you 97 irrational terms, and therefore number of irrational terms eventually is 97. So there are 4 rational and 97 irrational terms in this expansion. Nice question. Next we have 2 to the power 60 when divided by 7 leaves what as the remainder? Let's see. 2 to the power 60. Now obviously here we need to incorporate somehow 7. So I am going to write it as 1 plus 7 to the power 20. I can write like this. 2 to the power 60, I can write it as 1 plus 7 to the power 20. Here I am going to use my expansion. So this becomes 20C0 plus 20C1 into 7 plus 20C2 into 7 square plus and so on 20C20 into 7 to the power 20. I can take out 7 common. I will be left with 20C1 plus 20C2 into 7 plus and so on 20C20 into 7 to the power 19 plus 20C0 outside because it doesn't have a 7 in there, that is 1. So when I basically express it like this, I get 7 times something plus 1 where this particular term is strictly less than 7 and greater than equal to 0. So I get this can be written as 7q plus 1. 2 to the power 60 can be written as 7q plus 1 where 1 is greater than equal to 0 and strictly less than 7. Therefore, remainder is 1 when you have divided 2 to the power 60 by 7. So your remainder in this case comes out to be 1. Understood? And that brings me to an end of the discussion of these questions. Practice them nicely. That's it from my side. Thank you.